Welcome back, everybody, to another video lesson. This lesson is going to be talking about function notation. This notation isn't difficult, but if you don't understand it, it's going to be very, very difficult to understand and very difficult to read. So make sure you pay very close attention as we go through this one about the notation that we're going to be talking about. What I want you to think of here is these three functions up here, f of x, g of x, and h of x. What I almost want you to think of is think of them as each as a different kind of machine. Such as when right after high school, I spent 2 years at a Bible college in Minneapolis, in Plymouth to be specific. And I went to school in the morning and I worked at a part-time job in the afternoon. And what I did is I worked at a hardwood manufacturing company where we made hardwood doors that you open and close, so on and so forth. And it was crazy going into that warehouse and seeing how many different kinds of machines that there were. For a door to be made, I mean, it first has to go through the rip saw, and then it has to go through the planer, and then you have to glue some veneer on there, and then it has to go through different presses, and so on and so forth. And finally, out comes on the other end of these machines is something that has been transformed. Such as when I ran the rip saw, I put a board through the rip saw, and it cut off a straight edge on one side of the board. It went through one side of the machine and came out the other side of the machine looking different. And each machine that board went through, it transformed it in some way, shape, or form. So here's what we want to be thinking of as we do these problems. This -2 right here, it is going to go through a machine. It's going to go through one end of the machine, and it's going to come out of the other end of the machine transformed. It's going to look a little bit different because it's going through a machine that is changing it. And this F right here tells us what machine it's going into. Are we going to put it in the rip saw? Are we going to put it in the planer? Are we going to put it in the gluer? These are all different kinds of machines relating back to what I was talking about with my job. So this F of a -2, are we going to put it into the F function? Or are we going to put it into the g function? Or are we going to put it into the h function? Well, as you can see, it makes sense. If this is f of -2, we're going to put that into the f machine, into the f function. So instead of f of x equals x cubed minus 3, what you're going to do is you're going to say, well, I no longer want f of x. I want f of a -2. So if a -2 went in for this x, every time I see an x, I'm going to put in a -2 on the right side. So we have f of a -2 equals x cubed, which x is now a -2. A -2 cubed minus 3. So class, here's all that has happened. We just said f of a -2, we're going to put the -2 into the f of x function. And now if x is a -2, then we're going to put a -2 in right there as well. Now this isn't an equation where you have to solve, class. All you have to do is simplify the right side here. Once you simplify the right side, you are done. So let's just follow order of operations. First, we would use exponents. So we're going to use a -2 raised to the third power. A -2 times a -2 is a +4, and a +4 times a -2 is a -8. So a -8 minus 3. A -8 minus 3 is a -11. So our answer, f of a -2, is a -11. So as you can see, this -2 went through this machine. As it went through as a -2, it came out of the machine as a -11. And that's what I want you to think of when we're doing this function notation. We're putting these values into a machine in one end, and it's going to come out of the other end transformed a little bit. You guys pause the video now, try to do number 2 on your own, and then check it with me after you have done it. All right, so for number 2, g of 6. Hopefully you say, well, that g tells us what machine to put it into or what function to put it into. We're going to put it into the g of x function. So now, instead of g of x equaling 3x squared minus 3x minus 2, you're now going to say g of 6. The 6 is going into that g function. So now every time I see an x, I'm going to substitute in a 6. So 3 times 6 squared minus 3 times 6, subtract 2. Okay, all I did was use substitution to put a 6 value into every x that I saw. And now once again, all you're doing is you are simplifying this right side. So simplifying, we're going to have 3 times 6 squared, which is 36, minus 3 times 6, which is 18, minus 2. So now we're going to multiply. 3 times 36 is 108, minus 18 minus 2. So it's kind of like saying 108 minus 20. Our answer is 88. And it's always good to put this g of 6 out here because it tells you basically what you did. It told you that you put a 6 into the g function. When you put in a 6, it transformed that value into an 88 after it went through that machine. So my answer, g of 6 equals 88. Next one is a step higher in difficulty level because it's not just a number, it's also a variable in there. So the principle remains the exact same, just simplifying it becomes a little bit more difficult. So it says find f of 2b. This f tells us what function to put it into. Let's put it into this one. So instead of f of x equals x cubed minus 3, it's telling us instead of x, let's put in 2b. So whenever I see an x, I'm going to put in a 2b. So I see an x in the very first term, so I'm going to have 2b, and I'm going to cube it. 2b cubed. That number, subtract 3. And now all I do is I simplify this right side. So 2b cubed, that is the same thing as 2b times 2b times 2b. 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. And b to the first times b to the first times b to the first is b raised to the third power. Remember from intermediate algebra, when you multiply variables together, you add their exponents. So 8b cubed is what this becomes. And then I'm going to subtract 3. And this is as far as you can go, class, because I can't combine any more like terms. So my function of f of 2b turned into an 8b cubed minus 3. And there's my answer. Once again, you guys pause the video, try number 4 on your own. This one also got put into the f machine. So you're going to have f of a negative 3a is going to equal a negative 3a raised to the third power and then subtracting 3. I just put in a negative 3a into every x I saw in the f function. So now we're going to simplify this. A negative 3 times a negative 3 times negative 3 is a negative 27, and a times a times a is a cubed. So a negative 3a, that quantity raised to the third power, is a negative 27a cubed. Subtract 3. And once again, that is as far as we can go. So when we put in a negative 3a into the f function, we get a negative 27a cubed minus 3 coming out on the other end. Number 5. G of y divided by 4. So all this is a fraction, class. Once again, the principles remain the same on this one. We're still dealing with a value going into a certain function and evaluating it. Once again, it's just a step higher in difficulty level. Fractions are, with variables in them, are just more difficult than just a single number, just the way it is. But like I said, the principle remains the same. So this g of y divided by 4 goes into the g of x function. So if g of x equals 3x squared minus 3x minus 2, then I know that g of y divided by 4 is going to be 3 times x, which is y divided by 4 quantity squared, minus 3 times y divided by 4, minus 2. Continuing to simplify. All we need to do is simplify the right side here, and we're done. So we first have to do this parenthesis with the exponent. So y divided by 4 squared, y divided by 4 times y divided by 4 is y squared divided by 16. Here's my rationale on that. Y divided by 4 times y divided by 4. You multiply the numerators by each other. Y times y is y squared. And you multiply the denominators by each other and get 16. So 3 times y squared divided by 16 minus 3 times y divided by 4. 3 over 1 times y divided by 4. Multiply the numerators by each other. 3 times y is 3y. And 1 times 4 is 4. So 3y divided by 4. And then I still have my minus 2 at the end. All right, simplifying this one more step. 3 over 1 times y squared over 16 is 3/16 y squared, or 3y squared divided by 16, minus 3/4 y, or 3y divided by 4. Either way, subtract 2. And this, class, is what that is what g of y over 4 equals. G of y divided by 4 equals 3/16 y squared minus 3/4 y minus 2. All right, you guys try the last one on your own. Try to pause the video, please, and try to attempt that one as best as you can, and then check your work with mine at the end. H of a half. So this h tells us that we're going to go into this h function, and this 1/2 tells us that we're going to put it in for every x that we see. So h of a half is going to equal 3 times a half squared plus 5 divided by a half. And now all we do is we simplify. So a half times a half, we're doing this step right here first. A half times a half is a fourth. 3 times a fourth plus 5 divided by a half. 5 divided by a half is the same thing as 5 multiplied by the reciprocal. 5 times 2 is 10. So I have 3 times a fourth, which is just 3/4, and then we're going to add 10. So on a test, class, I would have no issue if you put the answer down as 10 3/4. That's a perfectly right way to do it. If you wanted to put it as an improper fraction, you would have 43/4. Either one is fine by me. So your answer for h of a half, when I put 1/2 into the h function, I get 10 3/4, or 43/4. I hope that function notation makes sense. It's not very difficult once you understand what the process is. So like I always say, be sure to ask me if there's any questions if you have them. Before we get to our assignment, here's one tricky problem that you might see on your Excel math. We're going to talk about this in great detail in Chapter 9, but Excel math puts it in right here. It asks you this question: is this one a function? And remember, what you do is let's see here. You know that if it is a function, it has to pass the vertical line test. So you're going to get a vertical line, and it only touches once, it only touches once, it only touches once, it only touches once. But now, class, when it gets to here, it looks like it touches more than once, doesn't it? And this is just something that we don't quite fully understand yet. What this function is it's a rational function, and this red line is an asymptote, is what it's called. and it looks like this blue line right here is following it, and it looks like it's going to become parallel with it or touch it, but it actually doesn't. It just becomes infinitely and infinitely closer to it. But class, this is a function. This blue line goes to the right ever so slightly as it goes down. So it keeps on getting further and further to the right. So because of that, it does pass the vertical line test. Even though it looks like it touches more than once right here, it doesn't. It touches at only one point. Same thing when I go up to the top on the right side of my y-axis. It might look like it touches more than once here, but it does not. It only touches once and only one time. So this one is a function. You would say yes. And not only is it a function, class, I know this might seem a little bit confusing, but it's also a one-to-one function as well. Because in the same way as it looks like right here it's touching more than once, it's not. It only touches that blue line one time, because as this blue line goes off to the right, it's getting closer and closer and closer and closer to the x-axis. So you're going to find the reason for that in chapter 9. For right now, just know that whenever you see a function, you might see one like this on Excel Math as well, where it kind of, I call it volcanoes. It might go like this, and then like this. This one is also a function, okay? If you were to do your vertical line test, it touches only once, and it continues to even right here too, even though it looks like it's touching more than once. So whenever you see those kind of graphs where it looks like it's curving and it's getting closer and closer and closer to it, those are functions. So yes would be the answer to that one. Certainly though, if you have any questions on those, I'd be more than willing to help you out with those and even explain them further in depth if you would like me to. So you have 3 accelerated math objectives for today, as well as you have another 5 or 6 problems on a worksheet that I'm going to hand out on page 61. It's in our books, but I'm not going to hand out the books. I'm just going to hand you a worksheet out instead. So that's what we have for homework. Let me know if you have any questions when you come to class tomorrow.